Hey everyone, thanks for joining us for the next session of our Python and MCP from local to production series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Pamela, thanks so much for joining.
Hello, everyone. Welcome to our Python plus MCP series. This is a three-part series. This is part 2 of the series. If you're just joining today and you missed yesterday, you can totally go back and watch the recording on YouTube of yesterday's talk and catch up. Everything is recorded and available for you. All the slides, all the code, so that you can watch after, rewatch, share, whatever you want to do. One sec. So I see we've got people joining from all over. Someone said they're joining from Japan, and I think it's 3 a.m. there. So kudos to people for joining from so many different time zones. That is really fun to just see everybody come together in order to learn MCP, which is one of the most exciting new technologies of this year. And I think we're going to hear a lot about it in 2026 as well. So yesterday we talked about how to build a basic MCP server in Python using the FastMCP package and how to run that server locally and use it locally, both from an agent like GitHub Copilot and from programmatic agents. Today, we're going to talk about how to deploy Python MCP servers to the cloud. And of course, we're going to be using Azure as our cloud since we're from Microsoft, but a lot of these concepts can apply to other clouds as well. And then tomorrow we'll talk about authentication. So definitely join tomorrow if you're interested in user authentication. So let's talk about deploying MCP servers to the cloud. You can grab these slides from this URL if you want to have a copy of the slides and follow along with them. And we'll share that URL in the chat here. For those of you who don't know me, my name is Pamela Fox. I'm a Python cloud advocate. That means my job is to figure out how to use Python with Microsoft technologies. And these days, it's a lot of generative AI and related technologies like agents, RAG, and of course now MCP. So in our topic today about deploying, we're going to talk about how we can take a FastMCP app, Dockerize it, make it into a container with Docker, deploy that to Azure Container Apps, add some observability using OpenTelemetry, and then exporting to different observability platforms like Azure App Insights and Logfire, and then do private networking with Azure Virtual Networks. All of the code for today is in this repo here, aka Python MCP demos. This is our main repo for this series. So if you haven't bookmarked this repo yet, please do. You can fork it, you can star it, you can clone it. You definitely want to keep track of it somehow. And everything that we're showing today is from this repo. Now, for today's session, because we are deploying to a cloud, you can't just follow along locally. You actually do need an Azure subscription in order to be able to deploy. So if you do have an Azure subscription, you can follow the README instructions for deploying. And if you don't have an Azure subscription, this could be a good time to get an Azure free trial. And we'll put a link to the free trial in the chat as well. And you can try deploying on the free trial. Now, sometimes a free trial does have some limitations. So if you have any issues deploying with the free trial, just let me know and hopefully I can figure them out for you. All right, so let's talk about cloud deployment of our MCP servers. So first, let me recap the MCP architecture that we talked about yesterday, right? So, we're building an MCP server. Our MCP server exposes a bunch of tools. It might also expose prompts and resources and, a few other parts of MCP, but most of, the heart of the MCP server is really exposing a bunch of tools that can then be used by other applications, right? So that's our MCP server that we're building here. And then we have, on this side, we have MCP clients that live inside MCP hosts, right? So in this case, this MCP host could be something like Claude Desktop. It could be ChatGPT. It could be GitHub Copilot in VS Code. Those are all applications that act as an MCP host that use an MCP client in order to interact with MCP servers. So this client can connect to the MCP server using the MCP protocol in order to say, hey, what tools do you have? Okay, great, thank you. Hey, I want to call this tool. Okay, great, here's a response, right? So it's just going back and forth between the MCP client and the MCP server in order to use everything that MCP server has. Now, our MCP host could also be a programmatic agent. Like we've got agents written in LangChain and Agent Framework. I want to put Pedantic AI, whatever your favorite agent framework is. All of those tend to, most of them have the ability to act as MCP clients as well so that they can communicate with servers. So that's our architecture. Now, when we're running an MCP server, we have these two options for the transport, meaning how are we going to do that communication between the clients and the servers? So in yesterday's session, we started off with stdio, standard input output, and that's where we actually ran the server using a, like a terminal command. So we were like uv run mcp server.py, right? And so that would run the server, and then all the communication would actually happen just over standard in and standard out, right? And so that can work pretty well when you're just running servers locally that are using a Python script or a JavaScript package in order to give you some functionality. But the other option is HTTP, specifically streamable HTTP. And so with this option, we actually set up a server at a particular port, right? So yesterday we set up localhost 8000/MCP. So that was our URL, and all the communication between the MCP client and the MCP server happened over that, over HTTP to that locally running MCP server URL. So that's generally going to be the more production-ready choice because we get all the benefits of HTTP, right? We know how to set up HTTP servers. We know many ways of protecting HTTP servers and how to expose HTTP servers in different ways to other services. So generally, I'm going to be recommending HTTP as the transport to use when you're taking your server into production. So when we do that, how it's actually going to work when we do the protocol is that the MCP client will send an HTTP request to the /MCP endpoint. And in this case, it's doing a post request and saying, hey, I want to call a tool. And this is using JSON RPC. So JSON RPC is basically just send a bunch of JSON that has all the information inside it about what method you're calling on the other server. So it says, okay, this is JSON RPC. The method we're calling is tools/call. And here's the parameters that we're sending to that method here. So we post this JSON to the MCP server. And then the MCP server responds and says, okay, great, I got your method request. I have called the tool. Here is the response. Here's the result. And now the client can process it. So this is what's going to actually happen when we expose this MCP server over HTTP. So when we want to run a FastMCP server in production, we're going to make an app based off the FastMCP and then run it using a production level server. So let me actually show the code for that. So going into this repo, we have this file here, deployed mcp.py. So I'll point out a few things, right? So here we import FastMCP. That's what we're using to make our server. And then down here is where we create the FastMCP server instance, right? So we say, okay, we're making a FastMCP MCP server. We've got some middleware, which we'll talk about later for OpenTelemetry. But really, it's just an MCP server with a name. And then as you go down, you can see we decorate and say, okay, this is going to be a tool, right? So we hang that off the MCP server, right? The MCP, mcp.tool. We've got another tool here, get expenses data. And I've got a prompt here. So all of that is part of this FastMCP app. And I've also, for production, I've added a custom route. This is my health endpoint. This is a general best practice when you're putting servers into production, is to have a health endpoint so you can check to see, have a common way of checking to see if the server is alive and working. So we can add this custom route here. It's not part of the MCP protocol, but we can attach it and say, hey, when you go to /health, we're just going to return back that everything looks good. All right, so then the important thing here is where we say, give me the HTTP app for this FastMCP instance. So what this does, it returns a Starlet application. Now, if you haven't heard of Starlet, and most people actually haven't heard of Starlet, it's actually incredibly popular, but most people don't realize they're using it. So Starlet is a Python framework. And it's a Python framework for creating. Okay, we should donate to PyPy. Good. So Starlet is a Python framework for creating ASGI applications. Now, ASGI means async applications, right? And generally, our recommendations in this modern age of networking and generative AI is to use async web frameworks. So Starlet makes it easy for you to make an async framework. Now, many people have not heard of Starlet, but in fact, many people are using Starlet because FastAPI is the most popular Python framework these days, and FastAPI is built on top of Starlet. So if you have used FastAPI, then you have actually used Starlet. FastAPI just adds a bit of additional functionality on top of Starlet, but all of the async routes, all of that functionality comes from Starlet. So similarly, FastMCP is built on top of Starlet, right? So Starlet is this, lovely async framework that's the core of many of these frameworks that sit on top, right? So when we're using FastMCP, we can specifically say like, hey, we need to get that Starlet ASCII app back out. So that's what this does here. It says, okay, give me the Starlet application because I need something I want to run. So we get that app, and here we're making it a global variable. So then once we have that exposed, then we can run that ASCII app. And there we want to use a production level server, and typically with async apps we're going to use Uvicorn. So we're going to use Uvicorn to run that app, right? So here we say, okay, I'm just going to cd into the servers folder and say Uvicorn, and this is the file, this is the variable name. So it says look inside this file, this Python module, find this variable. And then we're going to just run this on localhost just to show you. And we'll do port 8000 like we did yesterday. All right. So Uvicorn is a server that can run ASCII apps, and it's what we're going to use for production. You can also use it locally as well when you're testing out your servers locally. So here we can see that now it is running on 8000. We get a not found, but that's intentional. If we go to /health, we can see, ta-da, it's healthy. It's up. It's working. So that is how, so we're preparing our app for production, right? So we've got an ASCII app. We can run that ASCII app using Uvicorn, which is a production ready server. The next step is figuring out where are we going to actually, put this application. Where are we going to deploy it? So we're going to show how we can deploy on Azure because we're from Microsoft, but there's other options as well besides Azure, obviously. But hopefully, a lot of these concepts apply across the clouds. So for Azure, we've got this range of options for where to deploy Python applications, right? These are all possible places, all valid places that you could deploy a MCP server, right? And there's a spectrum here of how much control and flexibility you get versus how many managed features you get, right? And it's really up to you as a developer to decide, hey, do I need more control or do I want to take advantage of some of these more managed features, right? And then you give up some flexibility, but hey, you get the managed features, right? So here, on the most managed sides, we have Azure Functions, and they can be a great fit for MCP servers, right? They're very good at scaling up quickly, responding to variable load, being able to quickly respond to something. So Azure Functions can be a really good fit. There's lots of example MCP servers written in Azure Functions, and that team has made it very easy to bring your MCP servers to Functions. So with Functions, if you're going to deploy on Functions, you need your actual server file, like we just showed. You need a requirements file. We're using pyproject.toml. Let me show our pyproject.toml. So pyproject.toml is a standard way of defining all the requirements for a Python module. So here you can see all the dependencies that we have. The really important one is FastMCP, but we've got some other dependencies here as well. So as long as we have a pyproject.toml and our server Python file, that can often, tell an environment everything it needs to know. For Functions, you also do need a host.json, which describes how the function is going to work. Another option is app service. App service and Functions are similar. They actually share similar infrastructure. And app service will, if it sees a pyproject.toml, it will automatically build your Python package for you just based off of that pyproject.toml. So all you need for app service is actually the Python file and pyproject.toml. Then there's Azure Container Apps, and that is a great way of deploying containerized applications using Dockerfiles. So there, we're just going to add on a Dockerfile, and the Dockerfile is going to describe how to set up that Python package. And that's actually what we're going to be doing today, because that's my favorite platform for deploying. And on the most extreme end of flexibility, we have Kubernetes, right? With Kubernetes, you need a little more infrastructure setup. You're going to also add in a Docker compose.yaml to describe all the services you're setting up. And you might need a little more infra besides that as well. So that's the range of options. Today, we are going to focus on container apps and use that as our platform. So now let's dig into deploying on container apps. The first thing we need is to containerize our FastMCP server. For that, we need a Docker file. So here on the slide, I have a simplified version of a Docker file, and I'll step through this, and then I'll show you what our real one looks like. It's a little more complicated. But this is a Docker file. It starts off with a base image. So here we tell it to start with Python 3.13. So that's the Python version that we're using for our environment. Then we create a directory to hold everything. And then we install the requirements. So we're using the pyproject.toml in order to install the requirements. We also have a lock file from UV. So we copy over both that pyproject and the uv.lock file. And we make sure we have UV on the system and then run UV sync. And UV sync will check the lock file and make sure that everything in that lock file is available on this system here. Then we're going to copy the actual code into this container here. We're going to expose port 8000 because that's what we're running the server on. And then we actually start up the app, right? So we're using that Uvicorn command again and saying, hey, Uvicorn, run this app on 8000. And so then whatever's running on 8000 will get exposed to anyone who's trying to access that 8,000 from outside the container. They'll be able to go to 8,000, and 8,000 will map to the process running here. So that is a simplified version of the Dockerfile. Now, if we look at the real Dockerfile, it is a little more complicated. So this might be more what yours looks like for actual production. So first, we split it up into 2 stages. We've got a build stage, and that's what sets up all the Python package requirements. And then we have the final stage, and that's what copies the code over and runs it. And in this case, I actually used a shell script, an entry point script for running it because I did want easy customization of exactly what module it's going to run, because tomorrow we change it to a different module, right? So you can get a little bit fancier with your Dockerfile. This, I mostly split it up into 2 stages, both so I could reduce the image size and so that I can take advantage of Docker's caching abilities to cache the dependencies better separately from the code. So there you go. So we have a Dockerfile. You can use the simple one or the more complex one. But the point is to have a consistent way of installing those packages, copying the code over, and then running that FastMCP. So now we need to create our infrastructure on Azure for this container to run. So we're using Azure Container Apps, and when you use Azure Container Apps, you first create a Container Apps environment, and that's basically a virtual network that contains all your container apps. So you can actually put multiple container apps inside that environment. And then that container app needs to run an image, and that image could come from any registry. It could come from the Docker registry, a GitHub registry, a public registry, a private registry. In this case, I'm using Azure Container Registry. So I build the image, upload it to the container registry, and then the container app pulls from that container registry, right? But you could pull an image from anywhere. Now, if you wanted to actually try this out with the repo, you have to check out the repo, and then there are instructions in the README for deploying to Azure. We use the Azure Developer CLI in order to make it really easy to deploy. So you just run azd auth login and then azd up, and it will create all this infrastructure and container for you. And the reason it's able to do that is because we have an infra folder, and that infra folder has a bunch of Bicep files. Bicep files is what's known as infrastructure as code. It's similar to Terraform if you've worked with Terraform. And these Bicep files just declare everything that we need, right? So it says, okay, we need, we need Cosmos, we need container apps, we need OpenAI, right? Everything that we might need is all declared in this Bicep file. And all you have to do is run azd up, and it will create all of that for you. So I've already run that, so I can show you over here, right? So when I run that, it created a bunch of resources here in my Azure account. So you can see the container registry. I've got some app insights for storing the logs. I've got the container apps environment. So if I click on this container apps environment, we can see it actually does have a couple container apps. There's one just for an auth thing that we're showing tomorrow, so you can ignore that right now. Then there's the actual server. So that's the one that has that Dockerfile that I just showed. And we also have a container app that has an agent in it, because I'm going to show how you could have an agent in one container that's calling a server in another container, because that could be a really common architecture, is to be putting your servers in one container and then your agents in other containers. And then they're all communicating just inside that environment. All right, so now all of that is deployed. So let's actually use it, right? So if we click on this server, we can see the deployed URL. And if we go to that URL, we'll see that not found, but we go to /health. Okay, we see it's healthy. All right. So it is running there. So what I'm going to do is go to mcp.json and, so this currently just has all of our local MCP servers. Now I'm going to say add server. So I click this little button down here, add server, HTTP. And for the URL, I need to put in the container apps URL and then /MCP, because the actual MCP server is at that /MCP endpoint, and we need to tell it exactly the endpoint of that MCP server. So we're doing /MCP and give it a name, and then it just adds it here. So it's actually quite simple. You could also just write this yourself. We just have the URL and the type. So then I can start that server. Okay, it is running. And here, when I go to my Copilot chat, I can make sure it's enabled. So I can see it's enabled here. And here you can see it has two tools. So one of them is add expense and the other one is get expenses data. So this is a tool. Yesterday, we had this as a resource. This time I decided to make it a tool. All right, so then we're going to say like, okay, yesterday I bought a $40 avocado toast with fried egg on top using my Amex. All right, so now GitHub Copilot is going to see that we have this MCP server, and hopefully is going to decide to call a tool from that server. And it's working on a plan here. This is GPT-5 I'm using right now, so we get to see its whole thought process here. It looks like it did decide to use the MCP server. Okay, so you can see it says it's going to run at expense. It gives the name of that server that we just added, so that matches. And it says it's adding a new expense to Cosmos DB. So now in production, we are using Cosmos DB to store the data. Locally we're using a CSV, but obviously we don't want to use a CSV in production. So instead we use Cosmos DB. So you can see here, right? We get all the information, we add it to the Cosmos container, and boom, then it'll be in the container. So let's try allow. So it is running that tool now. And now it's, and it decided to, that's very nice of it. It decided to then call the other tool in order to verify that it worked. So, this is the beauty of MCP servers, is that I gave it some tools. It decided to both use add expense and get expense data in order to double check that it really, truly worked. That's actually the first time I've seen it do that. So it just depends on, which agent you're using. All right, so it looked like it worked. So now to verify it worked, what I can do is, it already verified, but what I am going to do is go to the Cosmos DB. Let me make sure this is the right one. Okay, so here's the Cosmos DB account. I can go to the Data Explorer and look at the items container, and then click on one of these. So here we can say the last one was food, and it says amount $40. Avocado toast with fried eggs on top. So we can indeed see that it successfully added a new item to this Cosmos container using that production server. Yes, yesterday I bought a lot of pizza. Today I'm getting fancier with this avocado toast. I saw there were a couple questions. So one question was about this infra, right? All the infra that set all this up, right? Like the Cosmos. So the question was, did a human write this, or, did I generate it? I wrote it. Well, I will say one thing. I am using what's called the AVM, Azure Verified Modules. So the Azure Verified Models try to use the best practices, the best security practices by default. So I do recommend using Azure verified modules. If you know Terraform, they're similar to like Terraform modules. So they are, officially maintained by Microsoft, employees that have the best practices baked in, and then you just have to override what's particular to your setup, right? So for like this Cosmos, I did add on which containers I wanted, right? So for this one, I said, oh, okay, I want to add this container, and I'm using category as the partition ID, right? So there are ways of generating Bicep. My preference is to use the Azure verified modules and then to just customize them with what I need. And also I recommend just taking other people's Bicep, right? So if you're looking for Bicep, go to my GitHub repo. You see all of these things that have a check mark in this AZD column. That means they all have lovingly handwritten Bicep in it. And I recommend just taking Bicep that already works. That's what I do. I learn from my past self, and I take from my past self. The other question was, why are we, once again, why are we using HTTP instead of standard input output, right? Because it's true. If you look at a lot of the MCP servers that are in the registries, a lot of them are standard input output. And I think there's a few reasons for that. One is that at the beginning, standard input output was the only way of writing an MCP server. So that's what everybody used, because that was the only way to do it, right? That was our first option. Then they added SSE, which was an HTTP way of doing it, but it was kind of hard to do. And then they added streamable HTTP. So streamable HTTP is actually the most recent transport option. So that's why, people may be slower to adopt it. The second reason is that, if it's a local script, then it doesn't cost people any money if they put out an MCP server that's just a local standard input output, right? Like it's, okay, you're just going to download the package, right? That doesn't cost them any money. When you're doing a deployed endpoint, that does cost money, right? Because people are actually sending requests to your server. So there is a cost involved there. And so it has to be worth it to you to actually want to do a deployed server. So there are reasons for it. There are ways that you can basically turn, if you have an stdio, you can turn it into an HTTP server really easily. There's all these packages that do that. I can't remember the name right now, but I could find it during office hours. So it should, in theory, be quite easy to switch between servers. So if there's one that's only available only over a particular transport, and you need it in a different way, you can just basically put a wrapper in front of it. But it's a great point. So you might decide to use stdio instead of HTTP, but I think that for production, that HTTP is actually the nicer option. And then the question was, how did I set the destination to Cosmos DB? So you can look at deployed mcp.py. There's quite a lot of setup in here that I kind of skipped over, right? So I'm setting all these environment variables on the container. So if you look at my, if you look at my container variables, you'll see that there's quite a lot of settings on it. So, there's the Cosmos DB account here, right? So all these environment variables are set on the container, and I set those in the actual Bicep. So the Bicep sets it up so that they're on the container once it deploys, and then I can make a connection to that Cosmos DB container. And then inside the actual tools, I can create items, and then in this one, I query the items from the container. All right. Okay. So let's keep going. We covered a few questions there. So we saw how we could use the deployed server from VS Code. Now, how can we use that from our actual, programmatic AI agents, right? So, yesterday we showed that we've got some examples using agent framework packages. So we have the Microsoft Agent Framework example here, which sets up an agent that has access to the MCP server based off a URL. And then we have a really similar link chain example as well. Now, for both of these, we can customize them really simply to point at our deployed server by simply changing the MCP server URL. And I've actually just already changed that in my .env file as part of my deployment process. So if I just run this this agent today, it should just work, right? So let me close this one. All right. So I'm going to just say uv run agents agent framework. Oh, I'm in the folder. Let me just move up a folder. Okay. So uv run agents / agent framework HTTP. All right. So it should run against our deployed MCP server URL because I've set that in my .env here, and it's loading in that .env. And yeah, so, and then we could even, let me see if I can look at the logs right now, and we might be able to see the logs happening as it gets queried. Let's see, listening, okay. Okay, here we go. Oh, we missed it. We missed it in the logs. That's what happens if you do historical, but we're going to show OpenTelemetry very soon. Oh, here we go. Okay, so here we go. So we can see a log there. And we ran the agent. And the cool thing, the interesting thing is that this agent actually messes up the first time it tries to call the tool. It picks the wrong value for some of it and gets an error. But then it corrects itself because this is an agent, right? An agent is able to call tools in a loop. So it makes the first tool call, realizes that it didn't quite use the right arguments, and then corrects itself and makes the second tool call here. So it says that it logged this 1200 gadget. So now we could check Cosmos DB again. Let me do a refresh over here of Cosmos. Where is, oh, there it is. Okay, refresh. I'll just go and click on that. Okay, load more. Wait, I'm going to go here. Just wanted to refresh. Okay. All right, now I see it. Okay. So here is the new, this is the laptop that it just bought. So there we've run it. So this is running the agent locally, interacting with that MCP server URL. Now we could also run the agent from the container. So in our agents folder, we also have a Dockerfile, and this Dockerfile, you can see very simply just calls the agent framework file, right? And so it should just immediately run this. So that's actually what it already did when it deployed earlier, is that it ran that. So we see earlier, actually, when it deployed, it also ran that purchase. So you can do, once you have a deployed server, you can use it from various places, right? So you might be using it from internal agents, maybe that are running based off of webhooks or cron jobs or something like that. And they could be running inside other containers, like in this situation here. You could run it from a desktop application like VS Code or Cloud Desktop. You could run it from a Python script, like many, many different options for how you could interact with that deployed MCP server. So now let's talk about observability and how we can actually see what our MCP servers are doing. So we are using OpenTelemetry for our observability. OpenTelemetry is a standard that says how applications should emit this observability data. So it says how they emit traces, metrics, and logs. Those are the three main types of data that gets exported with OpenTelemetry. So a trace is composed of these spans, and it basically shows like the timeline of what's happening when a request is being processed by a service. So it says like, oh, okay, we got this tool call request, and then we queried Cosmos, and then we got this response back from Cosmos, right? So all of that would be a trace of spans that show, what's happening and all the dependencies. And that's what I find often the most useful. Then there are metrics, and those are numeric measurements that can be helpful to understand how the system is doing. Something like, what's your CPU usage, what's your latency, that sort of thing. And then finally, there are logs. So when we're using Python and we're doing like logger.info, logger.error, logger.warning, those are all logs, and we can export that in a way that's compatible with OpenTelemetry as well. So those are the three main kinds of observability data that we want out of our applications. So for an MCP server, what do we want to see traces from? So remember, our MCP server is in fact a Starlet ASCII application that's processing route requests like to /MCP and /health. So we want to see every request that goes to that application. Then that app, is using FastMCP to process tools, resources, and prompts. So we want to know, hey, did you get a tool call? Did you get a resource call? Did you get a prompt call, right? We want to know specifically what part of our server is interacting with. And then our tools, they happen to call the Azure SDK, right? Because we're using Cosmos DB here. So we'd also like to see like, hey, for Cosmos DB, like what's going on with those calls, right? So that's the, the kind of the flow of what we want to see in our traces. Now, for each of these kinds of traces, we need to have instrumentation for that knows how to observe what's going on with that layer in the stack and then export OpenTelemetry traces. So at the top level for Starlet, there is a package called OpenTelemetry Instrumentation Starlet. So we install that. That's in our pyproject.toml. And then inside the application, we call that instrumenter and say, hey, wrap this app in this instrumentation. And when we do that, that's going to output all these traces for every single route request, right? And these are all following a standard across OpenTelemetry that says, hey, when you get a route request, it's going to be hp.route. Next, we want to get traces from FastMCP. So for this, what we did is we actually wrote our own middleware, and we just attached it to our FastMCP instance. And we say, hey, every time you get a request, you're going to call this middleware. So this middleware is actually in, it's actually in the repo. So you can check it out and see how we wrote it. And basically, every time it gets a request to do something, it outputs a span. And so here you can see the kind of things that are in the spams. It says, oh, hey, here's the tool call I got. Here's the arguments that I sent. And these are also all following a standard conventions for how MCP servers should trace their tool calls. Finally, we want to store the traces to Cosmos DB. Now, when we use the Azure SDK, by default, it likes to export to OpenTelemetry. We do set this just to make sure that it's using OpenTelemetry. But as long as we do that, then we're going to see traces from all those Cosmos requests as well. So now we're sending off we're exporting these traces, but where are they going to go? We need some place to actually view all these traces once we have them all exported. So for Microsoft, we have Azure Application Insights, and that's all a managed hosted application. It's in the portal, and we're going to be using that. There's lots of other options for observability platforms. Another one that I really like is Logfire. It's very popular with the Python community. I'm also going to show you that because that's quite fun to set up as well. So you've got a ton of options, lots of things that are OpenTelemetry compliant. So once you've got everything instrumented, you can use the OpenTelemetry platform of choice in order to see those traces. So in order to export to Azure App Insights, we're going to install another package, Azure Monitor OpenTelemetry, and then use this function, configure Azure Monitor. And that just looks at this Application Insights environment variable and just sets up everything based off that environment variable. So this is the easiest way to export to App Insights. You can do a whole lot more manual work if you need to, but if this works, you should use it because it's a one line and will set everything up for you. So now what does it actually look like, right? So we'll go to, let me show you the log. So here in App Insights, I've already opened up a trace so you can see. And this shows you like, okay, we got a request, we got a post to /MCP, and that post to MCP, try to call the add expense tool here. And we can see all the properties, and we can see the first time it did actually fail because our agent called it in the wrong way. So it got back this validation error. And that's interesting. That means like maybe my agent, maybe I need to give my agent more instructions to be better. But then it does recover, and then it calls add expense again. And this time it passes in the right arguments. And so it's able to successfully go through. It calls container, Cosmos container, makes a bunch of requests to my Cosmos account and puts it in there. So that is a full trace that shows all these spans that come from the different telemetry exporters that we have. Now we also have a dashboard. So I set up this dashboard based off of the logs we have. So then we can just kind of monitor this dashboard and be like, oh, okay, here's their failures. Here's the performance. I made a bunch of custom dashboard charts here, just using KQL, QL, which is like a query language for your logs, right? So you can set all of this up with App Insights. And this is all actually, it's all in the Bicep. So if you deploy from the repo, all of this will be set up for you automatically. So that is App Insights. Now, I did also want to show Logfire because I think it's a really cool platform. So with Logfire, we're going to add the package for Logfire. And then it also has a configure function to call. And we're going to set this Logfire token in our environment variable. So it's able to use that in order to send the requests. And then when I do that, then I get this, I can use the very pretty Logfire dashboard here. And so here I am going to focus on earlier today when I called my Logfire agent, and we can see here, let me make that a little bit bigger. Okay. So here we get the request from Starlit, and then we see this add expense tool call, and that's the one that has the validation error. And then it was successful, and then it called, then it called the Cosmos DB stuff. So it's very similar to App Insights, but all these observability platforms, they have their own way of approaching things. But what I wanted to show is like, okay, as long as we use OpenTelemetry, then it becomes much easier to view our observability data in any platform that is compliant with OpenTelemetry. So that is what I would recommend is to use OpenTelemetry. All right. Okay. So that was observability. We have 13 minutes left, and I do want to talk about private networking. So I'm going to go into private networking now. If there are questions that I've missed, we do have a full hour for office hours after this live stream, so we can talk about more things in that office hours as well for anything, any questions that aren't getting answered in the chat. So now let's talk about private networking, because here's the thing. Everything I've been showing you so far was with a publicly available endpoint. So in fact, any of you could have taken my URL and logged expenses with it, right? With your $300 of pizza or whatever, right? Like as long as you had that URL, you actually could have logged an expense. And that's kind of sketchy, right? And sometimes people rely on, security from obscurity, like basically like, oh, you don't know my URL, so it's fine. Like it's not going to happen. But it's very risky to have a public endpoint if you don't mean for it to be a public endpoint, right? So this is a stat we had where 84% of the attack paths and security issues are because of internet exposure, right? So if you have a publicly available endpoint, you really should think carefully, right? Like you really need to want to have that public endpoint. And otherwise, you need to protect that public endpoint. You can either make it private, which is what we're going to show today, or you can add authentication, which is what we're going to show tomorrow. So today I'm going to show how can we make that endpoint be a private endpoint and not have the risk of this public URL that anybody could use. So does a private endpoint make sense for you, right? A private MCP endpoint. So there's two situations where you might consider having your MCP server at a private endpoint. The first one is if you're making an MCP server for internal employees at your company, and those employees are already working on a virtual network, and they have like a VPN or some sort of way of working inside that network. Maybe they're actually on premise and that's how they're inside the network, but some way of getting into that network that is, particular for your employees, right? So then it could make a lot of sense to, put that MCP server on that same, accessible via that same virtual network, so that all the internal employees can use it and nobody outside the company can access it, right? That's the first situation. The second situation is maybe your MCP server isn't even designed for use by humans, right? Maybe your MCP server is only designed for use by other agents, and those agents are all internal on your systems, right? Like if you have these agents that are just running in cron jobs that are just like doing this, background analytics, right? So in that case, it doesn't make sense to expose your MCP server to the whole world, right? Instead, you set up a virtual network that has your MCP server, it has your agent, and they just communicate over internal networking with each other, and nobody needs to be able to actually go inside that network. So the way that we're going to set up that situation on Azure is that we've already got this container apps environment, and that actually, by default, that actually is a virtual network, but I'm setting up a new virtual network so that I can add some more things to it. So what I have is this whole thing is a virtual network, and inside that virtual network, I've got two subnets. And the first subnet is the one that contains the container app environment with its apps. And I've got what's called an NSG, which is a network security group. It's you can attach it to a subnet in order to come up with rules and say like, oh, you can only allow traffic over HTTP, only allow traffic at these ports. So it's just a way of adding more security to your subnet in terms of what can go in and out of the subnet. So we've got two subnets with NSGs that are all inside the same virtual network. And then everything communicates over using what's called a private link. So this MCP server uses a private link in order to communicate with the private endpoint of Cosmos DB. So there's also then something called a private DNS zone that resolves that private endpoint in the virtual network. So there's a lot of infrastructure that goes into this. Once again, I've already written that infrastructure for you. So it's all in the Bicep, so you can just deploy it and it'll get all set up. So everything is communicating over these private links to private endpoints using the private DNS zones. So that is the architecture that we're setting up. If you do want to try it out in the repo, you can follow the instructions in the README for deploying with private networking. You basically just need to set some AZD environment variables and run up, and it'll set everything up. So I can show you what it looks like once we have everything set up in the portal. There's quite a lot of infrastructure involved, a lot of resources involved with private networking, but it does make everything more secure once you have it all set up. So here, this is my private resource group. So this one you can see we've got private endpoints. We've got, a bunch of, let me sort by type. Okay. So we've got network interfaces, network security groups. We've got all these private DNS zones. And then we've got all these private endpoints. And then we have the virtual network itself. And sometimes the topology graph is cute to look at, and sometimes it's kind of crazy. But here is the topology of the virtual network. I think my slide made it a little clearer. But this is just to show there is a lot involved with a virtual network, and it can be a little bit of a pain to set up at first. But hopefully I've made that easy for you by writing the Bicep. So now we have that deployed. So I'll go back and actually show you how I know that it's all private. I can go to I'm going to go and open the Container Apps environment and look at the networking. And here you can see that public network access is disabled. So it is going to block all the incoming traffic from the public internet. No one can get into this environment at all. And we can see it is associated with a virtual network with this specific subnet, and that it itself has a private endpoint. So all of this indicates that it is all completely private, right? So that's all private now. And then we can see here, we can, look at our apps, and we see that we've got the agent app and we have the server app. So if we go to the agent application, we can check the logs and see what it's doing. So we can see it's working here. We can look at the historical logs, and somewhere in the historical logs, we'll see a call to the server where it actually made that request, right? So that's the general idea. We get it all set up, and then the agent calls the server. Now, this one, the agent only calls the server once when the server first starts up. In reality, if you had this sort of setup, you would either have a cron job, which was running the agent on a schedule and doing something, like every hour, every day, or you would have some sort of a hook-based system where, like, oh, every time that there's a new GitHub release, you're going to do this, or every time there's something added to the blob, you're going to do this, right? So generally, it's either going to be a scheduling thing or a trigger-based thing. Okay, so that's it. So it's the demo for it isn't very exciting because basically the point is, yay, we can't access it. Yay, it's secure. But the exciting thing is the fact that it is actually all set up and can't be accessed. Now we have another example that does set up kind of similar infrastructure. This is our AI travel agents sample repo, and this one sets up actually MCP servers in different languages. So it sets up like a JavaScript one, a Python one, a Java one, and that's kind of an interesting idea, as having multiple languages for services. And this is something you can do easily once you're using something like container apps, or you're just like, oh, we have a Python container, we have a Java container, we have a JavaScript container, right? So that might be an interesting sample to check out as well. All right, so we focused a lot on container apps today. There are other deployment options, which I mentioned in the beginning. So just to talk briefly about these other options. So Azure Functions, they do make it very easy to bring MCP servers. They have two different ways of doing it. You can either use the Azure Functions MCP bindings. And so there you're actually writing your function code very particularly for Azure Functions using the Azure Functions, package. And that's good because it's very built into Azure Functions. So it's going to work really well. However, they also did add support for being able to bring a FastMCP server and just using that for Azure Functions. And so that might be more exciting to you if you want to be able to deploy to multiple places. Like maybe you want on Azure Functions and also Container Apps and also FastMCP Cloud, right? So Azure Functions does support both of those options. I found this example from Anthony Chu on the Functions team, which is pretty fun, which deploys a Azure Function MCP server for weather. But the thing that's really fun is that it also uses the OpenAI Apps SDK. So it displays a widget when inside ChatGPT when you use it. So this is getting into MCP apps, the idea that MCP servers can produce not just data, but also UI widgets, like actually full interactive applications. So if you're interested in that, do check out Anthony's repo. It's pretty fun. Now, I also mentioned Azure Kubernetes Service. So with this, it's similar to Container Apps, except we also need to set up the entire, multiple services, right? So we can use Docker compose.yaml. So, we'd say okay, we have our MCP service here. We have our agent service here. Here's the Docker file for each of them. This is how we're going to connect them together, the port they're communicating over, and then put all of that on Kubernetes. And, then you want to manage all the scaling for Kubernetes. We do have an example that uses Kubernetes. This is the Zaba shop. And it's like a pretend retail shop, and it uses MCP servers for a lot of the functionality, and then has agents that do analysis based off those MCP servers, right? So there's one that looks at finances and tries to get insights based off the finances. and gives you a report back. So if you're interested in Kubernetes, check out that repo there. It's got all the infrastructure for it. Okay, and that brings me to the final minute. We have just made it, and I know there's lots of questions that we didn't get to, but that is why we have office hours right after. So basically, once we close down this stream, I'm going to hop into Discord and start up the stage in Discord. And you know, so if you have a question that didn't get answered here, just copy and paste it into Discord, and we'll try to answer it there. As a reminder, all of these sessions are being recorded and all the slides and code is available. So you can go to this resources link here in order to get all the resources, and we'll keep that updated. And then after the series, if you want to keep learning, we do have, my colleagues have this MCP for Beginners repo that, you know, has a bunch of tutorials about how to write MCP servers. So there we go. We're gonna close up the stream for today and go over to Discord. Thank you so much for joining today, and for all the great questions and comments in the chat, even though I didn't get to all the questions. But hopefully we can get to them in the Discord. I hope you join us tomorrow for talking about authentication, which is super, super interesting with MCP, how we can make MCP servers where we're actually doing things on behalf of the user. Really, really some cool stuff there. So hope to see you in the Discord or tomorrow. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.